Hi there. In this video, I will give you explanation to another interesting concept in Python called monkey patching. I did find a couple of YouTube videos even on this topic, just like the topic on duck typing, and I found almost all the videos have a similar explanation, and somehow there's some kind of a gap. When I looked up the examples for duck typing on YouTube, it's like everybody almost uses a class and gets a method inside them and so on. When it comes to monkey patching, also they create some classes and they put some methods inside it, and they're trying to talk about mock testing as an example, but just totally different. So here's what you should know what monkey patching really means. We do this in real world. Take an example. Let's say you bought a car, and sometimes when you buy a budget car, a car on a shoestring budget, the default settings or default features or accessories that come up with the car from the manufacturer might not be to your liking. For example, you might have a headlamp that's not really bright enough. You might be having a very basic halogen headlamp, or you don't like the way the dashboard looks like. The dashboard is very basic. So very often we make modifications to the car that we buy. We buy a basic car, but then we go to the aftermarket showrooms or places and garage, and we actually change the wheel to tubeless wheels, tubeless tires. We might want to change the car dashboard to have a GPS, satellite navigation system, or you might also change the headlamps to have a better headlamp, maybe a HID or a LED headlamp, which might be more efficient than what comes by default from the manufacturer as such. All of these, when you actually change the default features of the car, what you're actually doing is monkey patching. So when you actually, let's say you bought a car of a particular brand, when you go to the aftermarket shop or a garage, you go for a model that fits to that brand, right? Be it the dashboard or be it the tires. You look for the exact compatible versions. So this is the realistic example of monkey patching. In fact, there were times when I was a small kid in India, when the number of cars that were on roads were not as varied as what we see today. We used to just find, when I was a small kid, maybe in the 80s and the late 70s and 80s, we'll just find two kinds of cars in India: Ambassador or Premier Padmini. They're two popular cars. If you live in India, I guess you should be able to recollect that. And though you'll find a lot of Ambassadors on the road, there are certain Ambassadors that actually look very plush, and their engines sound very silent. The reason is because people who have a lot of money, they'll buy an Ambassador, but they'll replace the engine with an engine from Isuzu rather than the default engine from Hindustan Motors. They go for an Isuzu or an engine from Nissan, the Japanese manufacturers, which seems to be much more efficient and much less noisy. So this is also another example of monkey patching. We do this in real world. When we buy a lot of equipments or a lot of appliances, sometimes the accessories that come along with them, we replace with another alternative which is much better for our requirements. Well, in programming, we can do pretty much the same thing in Python. Not just Python. I think monkey patching is supported also in languages like Ruby, in Perl. So many dynamic languages do support monkey patching, partly or fully, depending on the language design. So here our focus will be on Python's use of monkey patching. In Python, basically, when you look at a couple of entities, modules, classes that we create, or functions that we create, right? User-defined functions, user-defined classes, and Python modules in general, they can be monkey patched. What do you mean by that? Is that you can change their attributes, change all their ingredients to suit your needs. Why would you do that? Well, there are for many reasons. Let's take an example of built-in functions itself. Have you ever observed sometimes that, let's say I have a string here, and I have another entity which is like, say, a list or a tuple maybe. There's a built-in function called len to find out the length of a string. It tells you there are 11 characters. Or you can also find out how many elements are there in a tuple by using len of nums. So len is a built-in function. Just an example. But what if I do this? What if I say len is equal to 100? Well, a couple of you might look at this statement and wonder, oh my god, how come Python did not raise an error or exception? How can you reassign len to 100? Now what happens after this? When you try to say len of a, you're going to fail. Int object is not callable. When you try len of nums, it's going to fail. It's not just with len. Just about all the Python built-in functions, can be what you see monkey patched. This is monkey patching, but this is not the real use case. This is a mistake, right? So why would I want to make len to 100? Do that, I don't think I'll get access to the original len function. Now here's what you should know about how this monkey patching works in this case. All the built-in functions in Python that you see, they come from a module called builtin. So when you actually say len, the Python runtime translates this to originally translates this to _builtin _len, right, of a or something. This still works. You can see this. The original len function is still in a module called builtin. So basically is this: when you say len is equal to 100, you created a variable in the current namespace that's called main. And when you create a name called len in the current namespace main, that monkey patches, that sort of completely clobbers the built-in namespace, right? This is a kind of monkey patching. What's a realistic use case for this? Take an example of print function. I don't like the default prints output. I want to change the output to add a timestamp to it. I can do that by monkey patching. For example, I could just do this. I could just say def print of, maybe I can say *args ** keyword args. I'm trying to make this function fully variadic. You can take variable number of positional arguments or keyword arguments. I don't really care. Take any arguments that you want. And what I'm going to do inside this here, I'm going to say runtime import ctime. Very simplistic. And I'm also going to say this time builtin dot print of, this time I'm going to say ctime followed by a colon followed by whatever arguments you get. Henceforth, in this particular code, when you say print of hello world, you can see what happened. I changed the built-in print function to my own variant, which always prefixes timestamp before printing something. Imagine putting this in the beginning of your Python code. So wherever you have print functions in the Python code henceforth, they'll all be hinged to your own version. This is one of the use cases of monkey patching. In the early days of Python, especially in Python 2 days, there were a lot of redundant functions. Maybe the best way to demonstrate, I'll just open up another terminal. I think I have Python 2 on my system. It's just legacy feature, okay? So you don't have to worry about this. The modern Python, modern implementations of Python, trying to increase the font size. Yes. Let me just try to see if I can bring up IPython 2. Don't have IPython 2. Okay, never mind. I'll just have Python 2. I have Python 2.7.18. I guess, in the Python 2 days, there used to be a function called range, which actually returns a list. Not very efficient. And there's a better variant called xrange, which will return a generator. So if you're using range function in thousands of places in your Python program and you want to make it more efficient, all you could do in the beginning is that, at the beginning of your program, you could simply say range is equal to xrange. So all occurrence of range is now xrange. This is monkey patching. I've just made range to become memory efficient. So every other code which uses range henceforth will actually end up using xrange. There could be side effects. If you expect the result of it to be a list, it's no longer a list. That's one thing you should know. But 99% of times people use range with a for loop. For I in range of 10 or I in range of 10, 20. Use this kind of a idiom. As long as you use the proper Pythonic idiom, this works perfectly fine. These are the examples of monkey patching. Another example I can tell you is this. Let's say you're writing a big framework in Python where you have loaded certain modules and you allow third-party plugins to work and coexist in your framework. Somebody could write a small third-party plugin that could be implanted in your framework and it would work, and you want to make sure that they don't wreak havoc. It's very likely the third-party plugin that's running as a part of your larger framework written in Python would have access to all the built-ins and all the modules that you've loaded. And maybe one such module that you've loaded is OS module. And now the OS module has a couple of dangerous functions. And one such dangerous function many of you may be aware of is the unlink function. Unlink is used to delete a file. So we just say os.unlink of any file name, right? I'm not sure if I just say os.listdir of dot. These concepts I've tried showing you in Python 2, but it'll work also in Python 3. Let me switch to Python 3 itself. It's on the terminal which uses Python 3. It's all the same. Let me just do an ls here. There are a lot of files in here. There's a file called testfile.txt. So if I just use import os and say os.unlink of testfile.txt, the file is deleted. The file got deleted. So if this code was run by plugin, not written by you, but we just got loaded as a part of your framework, you can't trust such plugins and you don't want them to run some dangerous functions like these. So what do? You sanitize the OS module. All the dangerous functions, you can delete it. You can just say del os.unlink. You know what it does? Just removes unlink function from the OS module. You don't want this feature, just remove it. And now if you try to say os.unlink of any file name, let's say virus.pl, I can see when I ran ls command there. This is also monkey patching. The ability of dynamically changing the attributes, which involves adding new attributes, removing attributes, or changing how the attribute works for an object, is what is monkey patching. You can do that for a module. You can do that for any classes that you create. You can also do that for any functions that you create. Monkey patching function, I'm not sure if there's any great use for it. Maybe yes. I could just create a function, let's say def greet, and I'm just going to say print hello world, a silly little function. Normally when I type greet, it just shows function main.greet. You don't want to show this function name as greet. Maybe because I reassign this function to something called welcome. I'm going to call this function welcome from now on. But when you actually type welcome, it shows its function main.greet. You can actually monkey patch this function. You can actually say welcome dot call name. This attribute actually represents the name of the function. You can change it to anything you want. If you type welcome, or even if you type greet, it shows the name welcome. You can actually change not just the function's name, you can also change the function's code. I'm not sure if there's any real practical use. I couldn't find one, but you can actually change the code object of a function to something else. Maybe you can just borrow the code object from one function, implant to another function. It's like brain transplant. You can do that. Monkey patching opens up innumerous possibilities like this, and this is what it is, right? So what are some practical use cases or advantages of using monkey patching? There are a couple of examples I can think of in the Python standard library itself. The Python standard library has a module called threading module. Many of you should be aware of that. So maybe I wrote a multi-threaded program, right? Why? Because I want to do multitasking. But then threads in Python have their own limitations. One of the biggest challenge with thread is this. You cannot really parallelize threads on multiple CPUs as of now because of the global interpreter lock. So there are a lot of these limitations. So you cannot run threads in parallel in multi-CPU architecture. Maybe you want to just do parallel processing, but you wrote a big multi-threaded application, but they don't leverage the multiple CPUs. As long as the threads are not doing something very sophisticated, each thread is running independent functions, which don't share any data and all that. If they're well designed that way, if they're all working with independent functions, independent of each other, it's very easy to monkey patch. You know what you could do? In the beginning, you would have had from threading import thread like this. That's how you create the thread class, right? And you could actually create a thread and do many things. What you could do is that you could actually say, replace that line with another line which you say, from multiprocessing, import process as thread. When you actually do this, the process class replaces the thread class. And the beauty is that the process class to a large extent is fully API compatible with the thread class. You say thread constructor, what arguments it takes, the same is also available in the process constructor. I'll do one thing. I'll just show you a small example by writing a small piece of code in here, which is multi-threaded, but I'm going to just monkey patch and make it multi-process and demonstrate it on a Linux system. You can see that in better view, right? So I can just do one thing. I'll just come out of Python in here. I'm going to stick to Vim editor this time. You could use Visual Studio Code, any of these things. I'm on a command line. I don't want to open up another window. So I'll just say class test.py. Initially, this is going to be using threads. So what I'll do is I'll just say from threading import thread. And let's say I have a function called foo, which does nothing interesting. It just maybe sleeps for 60 seconds and then exits. So we could just say, maybe I can just use from time import sleep, and I can just print a message in here. I'll also print a message. I'll also use from threading import thread. I'll also use something called current thread. Okay, current thread. So this current thread would indicate the thread object executing the current code. It's a function, right? So in here I can just say print. Use a format string in here. I'm just going to say current thread sleeping for 60 seconds. And for a sleep of 60. 60 is too long, so I'm just going to make it 30 seconds. I think that's sufficient. Nobody wants to wait on my video for 60 seconds, do you? I'm just going to make it 20 seconds now. And then I'm going to say print format string current thread woke up. And what I'm going to do is, in the main boilerplate, I'm just going to create about 10 threads, right? Which will, all the 10 threads will invoke the same function. So I'll just say tasks equal to empty list. Therefore, I can say maybe I in range of 10. I don't think I really need this, so it's okay. I could just use t is equal to thread of target is equal to foo. This is a constructor parameter that thread constructor can take. I can start this thread and I can just say tasks dot append of t. This creates all the 10 threads, and then I'm going, once it exits the loop after creating all the 10 threads and starting them up, I'm going to wait for all the threads to complete. So I'm going to just use for t in tasks. That's a t dot join. So we wait for each thread to complete sequentially. I believe because all threads sleep for 20 seconds, so I think this would work, right? So this is what I did. You can see that this is a complete program that uses threads or multi-threading. When I run this the terminal by using Python task test.py, I'll open up another terminal just to show you what happens when I run this. You can see that creates about 10 threads, and you do a PSAX on my Linux system. There's one multi-threaded application. The small L here indicates it's multi-threaded, right? There's a single process with multiple threads in it. It finishes in 20 seconds. I'm not sure if I can see by this time, but let's see. 5/tasks. Oh, I think it finished by this time. 20 seconds have elapsed. So all the threads woke up and they exited. Now, one of the things that you can see is that it's actually using threads this time, and I told you that threads don't parallelize. So if at all I want to switch to use processes, all I could do is just modify this code this way. This whole code is multi-threaded. Just comment off this line, and then here you say from multi-processing import process as thread. Actually, it's called current process as current thread. To actually use this. This is monkey patching. You can see that from multi-processing module, I'm trying to load process, but in the name as in the guise of thread. So when this rest of the code thinks it's creating a thread, it actually creates a process instead. When you're trying to use current thread here, you're calling current process instead because it's all aliased, right? So now we can see this. When I say Python task test.py this time, you can see it actually created 10 processes, not 10 threads. And if you just go and check it up as a proof, just do a PSAX here. Well, you can see there are actually total 11 processes. The main process plus 10 more processes being created. There here. This is a real example of monkey patching, right? So you could actually see there are many modules that does that. Another example I can think of is LXML library. LXML can fully replace the built-in ElementTree. So if you've written a program which uses ElementTree library for parsing XML, and for some reason you believe that you want to have you want to improve performance, right? ElementTree, which is in the standard library, is not a really high performant implementation. lxml, on the other hand, is the fastest XML parser. I'll not say fastest, it's much faster than the built-in ElementTree parser. The built-in ElementTree in standard Python library is just a reference implementation, which is good enough for most cases. But if you're looking for more features and better performance, you want to use lxml. And how do you use lxml? You just write ElementTree program, a program that uses ElementTree. In the beginning, you'll use ElementTree as import xml.e3.elementtree as et. That's a very common alias that you use. Comment that line and then say import lxml.e3 as et. Done. The rest all code will work using lxml. It's a drop-in replacement, right? You'll find many frameworks, many modules available in Python which act like a drop-in replacement for another existing module with a better implementation. And they do it deliberately so that you can monkey patch them. You just have to flip the imports and the rest is taken care of. It's just like you have a default engine which you don't really like in your car, which is very noisy. It makes a lot of ticky noise. So you just replace that engine with a better equivalent, which retrofits exactly into the same place, right? That is what really monkey patching means. You can also do that for your own classes. If you have created your own classes and you believe that there's one method in the class which is not what you want, you can actually say class.method is equal to a new method. You can change it. You can change the attributes of your class. You can change the attributes of instances of your class, right? You can also, as I showed you, can change the attributes of modules. Like it can delete an attribute, can change the attribute. For example, I did a los.unlink in one of the examples I showed you in here, right? Somewhere down, somewhere up. I remember I did this, right? I did os.unlink. So instead of os.unlink of s.pl, it doesn't work. But maybe you could do this. You could actually create your own variant of unlink, which might not delete the file, but maybe move the file to a safe location. So maybe you could actually create your own function where you can just say def your own unlink replacement, right? Which will take a file name, maybe whatever file name that's being passed here. Think of path. And maybe what you want to do is that in here, you might want to just say os.rename. Rename in most Linux and all the Unix environments, I guess even on Windows, can also work as move if you have a alternative folder path. You can actually say rename a path to, maybe you could just say /temp. Maybe store it in some location, maybe our /recycled or any place like that, right? You create your own folder that actually maintains all those reader files. Just move it there. So you can just move it into this particular folder. It's a very simplistic example, okay? Just giving an example here. And then I can just type os.unlink is equal to unlink replacement. So this time, when I actually delete a file, I'm not sure if there's any useful file here. Task.py. I'm just gonna try deleting it. I'm just gonna say os.unlink of task.py. Oh, okay. I think not a directory error. I'm not sure why. Maybe I think /temp is not accessible from this particular path. So it looks like it's not going to work. Maybe I'll create my own custom directory. Here, I will just say /home/ ranger/ maybe we can just call it trash. Maybe what I can do is I could actually create that folder. Right now, that folder is empty. Now I'm just going to replace os.unlink with unlink replacement. Now if I try to use os.unlink of task.py, I would say it's a directory. Okay, I think that's a problem because rename expects the path to be there. I think it expects the path to be there. It says it's a directory error. So maybe I could actually change this to / not the best solution. You should be using os.path module or pathlib module for better features. I'm trying to be lazy right now. show you the concept of monkey patching, right? So it's going to be very simple. You should make it even better than this code, right? But anyways, if I try running this now and I say os.unlink of task.test.py, it seems to have worked. You can see that file is missing from the current directory, but it's actually gone into my trash folder. Yeah, it doesn't handle real paths effectively, so you need to take care of various things. You might use the module's path labeler module and manipulate it. All right, but still, you get the point. You can actually change the built-in implementation of certain functions like unlink or any other dangerous functions to safer alternatives if you want to, right? Or if at all you have a function that seems to be quite slow, the default implementation, or less featured, you could replace it with something, an alternative which might have better features or maybe faster. And that is the truest use case of monkey patching. The last thing I should tell you is I learned the true essence of monkey patching when I actually encountered a framework called gevent library, which is quite magical. For example, if at all I want to create a multi-threaded application, I'm not sure how many threads I can create. I'll just do this over here. Just try this. I'm going to show you a program called thread flood. I use examples in many of my trainings. I say from threading, import thread. And I'm just going to create as many threads as I want. Yeah, by the way, don't try this on Windows. If you're using Windows, don't try. I have tried this on Windows earlier. I'm not sure. I've never tried on Windows 11 recently. But I think the last time I checked on Windows 10, it froze my system. This code can freeze your system. Better be careful. Try this on a Linux system or a Mac OS. It's quite safe, right? This code. Because it's going to create infinite number of threads. Not really infinite until the system just gives up, right? Generally, the operating system will have a threshold on how many tests can be created on a per application or system-wide basis. That happens on Linux and most Unix environments. So you can see that happening here. So I have a function. I'll call this function foo again. And even here, I'll just do nothing but time, sleep, and just going to print a message. Print. I'm going to use current thread and everything, okay? Started. I'm going to put sleep for 60 seconds in here. And after that, it's just going to exit. It's nothing much. The main boilerplate as usual. I'm going to create as many threads as I want. So I'm just going to use from itools import count. Itools module has a construct called count. I'll use the word construct. It's not a function, it's a construct, right? So it's actually a class. So when you use this count construct, you can actually, it's like range, but without a stop value. It goes on forever. It's useful for writing infinite loops, infinite counting iterators using for loop. So you can actually say for I in count, it'll go on for infinity. And I could just say thread of target is equal to foo dot start. Create a new thread and start it off. That's it. So infinitely it'll keep creating new threads, right? That count will keep the for loop running infinitely, and you can see create threads. I'll also put a print in here. I can just say creating thread and I, because I don't want to start from 0 this time. I start from 1. So it'll stay creating thread 1, thread 2, thread 3, and so on. Let's see how far this runs normally. I'm using the standard library threading module this time, and I'm running this on Linux system. This is a 64-bit version of Linux, so it'll let me run quite a number of threads. I think we'll see it'll give up after maybe about 32,000 threads or something. But let's try this. It's actually getting so many threads, but then you'll see after a while it will just give up. If it when I tried out on my Mac OS last time, not the latest on the M1 chip, but I have a very old aging Mac, a 2013 model, which runs on Mavericks, I guess even now. It actually stops at 2000 threads. I think the moment it goes to 2046 or 2047, it just stops right there and says cannot create new threads. But on Linux system, I think it last time I checked, it went up to only like 32,000, 32K. right? So it stops, yeah, you can see that, like 32644, roughly 32K. After that, it says can't create new thread. This is a limitation, right? This is got to do with operating system level threads. Each thread that you create here creates operating system level threads. Also, I'm not teaching you threading, but I'm just trying to show you that there are limitations with this built-in threading module. You can fully circumvent that by doing this. If you have gevent library, you could simply say from gevent import monkey, and then say monkey.patch all. Actually, there are two statements, so I'll put it in the same line, just like in the gevent manual. In fact, if you want to learn how to use gevent library, you just need this one line. Done. And you just know about your standard threading module. Everything works as expected. You know what this does? When I say from gevent import monkey and say monkey.patch all, monkey is a submodule in gevent. This patch all function will replace the threading module's thread class with gevent's threading thread class. And that thread class from gevent library is an alternative implementation of thread that uses what we call as greenlets, which does not use operating system level threads. It replaces the sleep function from time module with gevent.sleep, which will yield out the CP before blocking. All the blocking calls are monkey patched. That's what happens when you do this. I'm going to show you after this what happens. The set plot actually stopped up to 32K, right? And it was slow. You can see it took some time to reach here. Now I just added that line. The rest all lines are just as is. I said from threading, import thread, current thread, but it's all monkey patched to use gevent equivalents. But when you now run this, oh, I have not installed gevent library. Sorry about this. But maybe install gevent will do. Yep. Run this. You can see it's quite fast. It actually runs much faster than before. And it doesn't stop at 32K, it goes beyond it. Because every thread created this time is not operating system level thread. It's not a lightweight process. It's all user land threads or user threads which you can call, or green threads. Technically in the gevent speak, they call them as greenlets. And that's what is getting created. So it can go up to my system running out of memory. Until my system runs out of memory, it can keep going on. You can see it hits 37K, it'll hit 40K, it goes on forever. So you can see that this is an example of monkey patching, changing the default implementation to an alternative version with the same API. The rest of the code, you don't have to really worry, right? This is a truest model of what monkey patching is. So if you are going to be creating your own framework, your own library, and if your library is going to replace an existing library, how do you make it monkey patching compatible? Just by making sure that your library is exactly having the similar API, similar interface of the contract, like the built-in library or the existing library, but your implementation is totally different. Having an alternative, efficient implementation. This is how you apply monkey patching. So I hope you understood what monkey patching is, right? I didn't have to go to mock patch, mock test and all those examples. There could be like fringe examples where monkey patching could be used, but the truest essence of monkey patching is to replace an existing object attributes, which could be methods, or existing objects themselves with an alternative equivalent, which is similar in terms of API or the interface, but have an alternative implementation for the better. I hope you found this explanation useful. I hope you found the video useful. So if you do have any further queries or clarifications, please feel free to comment on this video. So I will try to answer them when I get time. Thank you very much. So meet you in another one. Thank you.